Very good morning. We will continue with Univariate Descriptive Statistics today. We will discuss characterizing a population, how probability distribution, particularly the discrete and continuous probability distributions, can be used to characterize a population. We will then discuss what is sample, what do you mean by statistic, and what are the different descriptive measures of statistics, primarily the measures of central tendency and measures of dispersion. Let us go ahead.
This is important because suppose you think that you are producing something and your the variable of interest follows normal distribution. Now, from data you are seeing you will get like this, distribution is like this. What will happen that the spread of this particular variable values within plus minus 3 sigma level, 99.73% of the items produced will fall under within this. Now, what will happen if the customer will not be interested at this wide range? For example, suppose this is my quality characteristic X and this one is the lower specification limit. This I am giving you the physical interpretation, and suppose this is your upper specification limit. Then what will happen ultimately? Suppose this is the mean one, but your normal, this follows normal distribution and your distribution may be like this. So, this may be, let it be minus 2 sigma plus 2 sigma. So, that may what will happen ultimately, that 5%, almost 5% of your production is reject product, because people, that customer will not accept it. So, when I talk about, say that characterization of the process, that means with respect to this distribution, that means this is your process, exactly that this is the soft representation of the process. You are not going to the subfloor, but this is the case, but your customer distribution is here and you are producing at this level, 5% of your production is not accepted by the customer. You want to improve it. You are getting me? You want to improve it, how you will do it? You just, can you explain this figure? This figure you see, this is again basically, as I told you, that characterization of a process through probability distribution. This is another example. The quality of service provided measured on a 100-point scale at 3 service centers A, B and C is normally distributed as N89. 80 stands for the mean value, 9 stands for the variance, because our general notation what we will be following is normally distributed, N stand for normally distributed, then mu, first is mu, comma, that is sigma or sigma square basically. So, mu is this and sigma square is this. This is the general notation we will be following all through. Then your second process, suppose B 80 16, third one is 99, and I have plotted the probability distribution for all the 3 processes A, B and C. And please remember that your variable of interest is quality of service provided. If I ask you which process is better, you will say C, yes or no? Yes. Why? Mean, yes, you are right. So, mean value is 90 and it is quality of service provided. On a 100-point scale you are measuring, higher the value the better the process. But parallelly you see the variability is 9. So, both from mean point of view it is at the higher level and variability point of view it is at the lowest level when you compare the 3 processes. Now, if I ask you from compare A and B, which one is better? A, because the variability is low, mean at the same level 8. So, what is the physical interpretation of this then? Physically what happened, it is the variability, the most difficult parameter, very difficult to control variability. I am giving you another important good example here. Suppose you think that you all know that archery, this one, suppose this is the bullseye, that one our this the gold medal winner, what is his name, that bullet gun, I don't, anyhow. So, this is the target. Now, someone, all shoots are here and someone shooting is like this. This is the bullseye. You are the trainer, two shooters A and B. Who, by training, who will be improved first? First one. The precision is first one, the precision level is higher than the second one. What will happen? You can shift this is the mean value, to this. But here it is a variable one. Variable, when something is variable, very even for the student's point of view, some students are very erratic, irregular, very difficult. But some student may be because of some reason very regular, but suddenly, or they are basically coming late by some few minutes always. You can, but they are still coming. You can motivate them, and so this is the physical meaning of the distribution. Now, we will come to the next important concept, is called sample and statistics. So, we have seen so far that population and parameters, and please remember the random variable is there everywhere. So, population and parameter. When you talk about population, we definitely talk about parameters, and we talk about in the particularly for this subject the probability distribution also, probability distribution of the variables of interest, variable of interest, that is x, variable of interest x. Now, see, you are planning to collect data. What you have thought of, that I know my variable, that variable is x, I want to collect data. How many data you want to collect? You want to collect n data points. What can you say about each of the observation? What can we expect? Getting me? So, if x is normally distributed, suppose x is normally distributed with mu and sigma square, that means x 1 also normally distributed with mean and sigma square, x 2 is normally distributed with mean and sigma, because they are coming from the same population. There is no guarantee that when if you go, you will observe some value of x, somebody else will go, he will observe some different value of x, even though the observation is the first observation. For you it is first, for him also it is first. Keep in mind this one, this is very important concept. You have not collected data, that is before data collection, you are planning. You are planning that you will be collecting data, n data. So, x 1 to x n, first you observe x 1 like x 2 like x n. Now, what is the issue here? All these values are random, as if they are basically x like, random and unknown. Okay. Now, you thought that you have collected data. After data collection, what will happen? So, you will collect data, we am denoting in terms of small x, let it be this small x. So, x 1, x 2, x I, x n. What are these values? known values realized, every value is realized, known and constant. This is in the population domain, this is now sample of size n. You see this slide here, before data collection you have planned to collect n data points and these are unknown and random, and when you collect data, after collection they are already known fixed values. That is a big difference. And another important concept you keep in mind that all the observations, each of the observations will follow the same probability distribution. By same probability distribution we are meaning that if it is normal distribution with mu and sigma square as mean and variance, x1 also has normal distribution with mean mu sigma square as variance. Once data you have collected, forget about all distribution. Now fixed value, there is no randomness in the data, it is already collected. The this one, can you remember that example, last example, that small company. We can give a name to this company. I have given that City Can. So later on I will use the word City Can. The company name is City Can. So these are the profit, sales volume, absenteeisms, all those things. What is this? Basically we are characterizing that City Can process in totality in terms of these variables, and your sample mean and sample variance. These are the statistics with respect to population mean and population variance. Correct. Do you know what is this? This is dot plot. Dot plot is something like this. Dot plot is something like this. Your variable is x. You arrange from the smallest to the largest. Now suppose this is one value, this is second value, this is third value, like different values are there. Suppose this value there is you have two observations, there let it be 3 observations, here let it be 5 observations. This type of plotting you are doing here. So again this suppose this again 2 values, this is let it be 2 values like this. This is known as dot plot. Dot plot again it is similar to histogram plot. Now here you are able to count the number of observation against each of the values of the x. So it will help you to find out the mode. Suppose if I say for this example profit in rupees million, you say 9 million rupees case it is 2 observations, for 10 it is 3, for 11 it is 4, for 12 it is 3. So that means the mode of the data points for profit is 11. Mean you have already seen, median is the middle value. How do you compute median? For computation of median you have to find out the position n plus 1 by 2, where n is the number of observations. In this particular example there n equal to 12 because 12 months data. So 12 plus 1 by 2, that means 6.5. So 6.5 means when you arrange your data from smallest to the largest, you just find out the position, then 6th and 7th position. Suppose this is your 6th position, this is your 7th position, you take the average of these two values, 6th position value, 7th position value. Okay. So and what is the mode? Mode is the value of x for which there are maximum occurrences, and this is the calculation for that data, and using Excel sheet you can very easily calculate this thing. Now measure of dispersion is this. What we have seen that that if the data follows suppose normal distribution, then this one is mu and this side how much it is going and this side that is percent. There are several ways to measure dispersion. One is range, that is minimum maximum minus minimum value. Another one is interquartile range, which is the third quartile minus first quartile, and these are all position. First quartile is basically n plus 1 by 4, and your quartile 1 position q1 position is n plus 1 by 4, then q2 position is the median, which is n plus 1 by 2, and q3 position is that is third quartile, which is 3 into n plus 1 by 4. So, all those position values you have to find out and then appropriately you have to manipulate the data. So, if there are two values it is coming in the middle, then you take the average, and if it is coming not middle, maybe right and more than the middle 7.75 position, suppose 3.75 position. So, accordingly that 7.75 that weightage to be given for the data. Okay. And these are all very simple thing you will be able to find out, but these are equally important and you require to know also these things. And you know the variance also, yes or no? How to compute variance? Statistical sense, a square is 1 by n minus 1 sum total of I equal to 1 to n, then xi minus x bar square. This is the variability measure. This is the variability measure. Why this n minus 1?
Actually, there are two definitions. This is MVUE, minimum variance unbiased estimate.
Minimum variance unbiased estimator.
According to this, it is n minus 1. But if we take maximum likelihood, then it will be n.
Okay. Any other explanation? Now, later on you will be discussing very frequently the degrees of freedom. Getting me? Degrees of freedom. We will be using DOF or DF. Now, see, in this case this n minus 1 is coming because of degrees of freedom, because you have n data points x1 to xn, and when you are computing this variance you require what you require? You require x bar to be computed. So, as x bar is computed with this formulation. So, what is happened ultimately here, when you find out that xi minus x bar, x that is x1 minus x bar, x2 minus x bar, like this, for the last one you do not require to compute, it is automatically computed. So, I will write here suppose xn minus x bar. What I mean? I mean that suppose if I write like this, sum of xi minus x bar, what will be the value? Xi bar. So, it will be now what is mean value? So, that means summation of xi minus summation of x bar, this is n x bar minus n x bar. So, this is 0. So, what will happen ultimately? You are not getting in my n x minus x bar values, one value is gone. Very simple other way, if you say suppose I have given you one equation x plus y plus z equal to 5, what is the degree of freedom here? You see that if you change x and y, z cannot be changed further, it is fixed, even though the three values are there, but you have 2 degrees of freedom, because I have made it is made as 5, and in this case also the same thing is happening, that sum of all those this will be 0. So, you require how many data points you have in s minus 1 square calculation? N minus 1. That is the another explanation of why n minus 1 will be divided while computing this. Now, I will finish this lecture. See, we have told you that normal distribution is very important one, and later on for this subject multivariate normal distribution. So, we must know that who is the father of normal distribution, and you see that Abraham D. Multivariate, this French born English mathematician, he basically has given the general form of this normal distribution. What form? You will see that 1 by root over 2 pi sigma square e to the power minus half x minus mu by sigma to the power square. Okay. Now, he is considered the father of normal distribution, but only equation will not be sufficient. Later what happened, that Gauss, he is another famous mathematician and statistician also. What he has given the properties. So, all statistical properties of normal distribution is identified, tested by Carl Friedrich Gauss. He is basically that German mathematician. Okay. And if you see, I think this is very interesting. It is not knowledge, but the act of learning. Please, it is not knowledge, the act of learning, not possession, but the act of getting there, which grants the greatest enjoyment. So long you are, suppose you are doing PhD, so long you are not getting PhD, you are thinking, okay, once I get PhD, I will be very happy. But it is not true. Once you get, within 2-3 days, you will find out that you are the same person. But the learning, going there, the act of going there, that is what is very important. And these famous people, they have quoted, and we must obey to their all suggestion. Thank you very much.